So we can download Maven from the Apache site. So I'm just opening it here. So here you will see download Apache Maven 3.0.4. So this is the ideal link where you can download Maven. Probably the versions will keep moving, but this is the location where you can download. And here what do you need to download? Always when you try to download the binary part of it. That's how you can use Maven. If you want to extend Maven, add your own functionality to Maven, you have the source available. But I think at this point of time you are learning Maven, so download the binary zip file. So you need to download this one into your machine. So just click on this. It will just download things for you. It will set it up in a few seconds. So it's downloading the stuff. Okay, now just go ahead and extract it into a location. So once I download it here, I need to extract it to a new location. Let me make it as Maven. Let me create a folder Maven and let me extract it here. Okay, I'll extract it here itself. So it's a very small download, and you can do it in a couple of seconds. So it's extracted for me here. You can see this folder Apache Maven 3.0.4. Okay, this is how you download and you extract things. Now once you take this up, you need to set up Maven in your system. This can be done by making changes to two environment variables. While I do that, please look at the screen. The first thing is you need to set up a variable called m2_home. If you do not have Java home set, then you need to set Java_home pointing to your JDK location. But since we already have discussed and there we have set Java_home variable, so we need not set that again now. We need to set up an environment variable called m2_home. So I am just setting that environment variable now. My computer, properties, environment variables. Click on new. Name the variable as m2_home. Then set the variable value to the location where you have extracted your Maven zip. Click OK. So we have set up our first thing. We have set up an environment variable called m2_home. The next thing that we need to set is to update the path variable. So again, go to environment variable section, m2_home. We have set. Now go to path section. Click on edit. Remember, path is an existing variable, and by chance do not overwrite with your new values. Don't create a new variable called path. It will trouble your system. You click on path and you click on edit. So it will open up the path and its existing value. You go to the very end of it. You go to the very end of it. Place a semicolon. You go to the very end of it. Place a semicolon. Give me 1 second. Now you come to your Maven installation. In Maven installation, take up to the location of bin, inclusive bin. So take this value Maven installation /bin. Now again edit your environment variables, and at the very end where you have placed semicolon, you just place your Maven/bin. Okay, click on OK. So these are the two things. that you need to do to ensure that Maven is configured on your system. So how do I know if I have configured Maven correctly? Go to command prompt and you type mvn and say, for instance, to know the version of Maven, we have an option --, version. You just type mvn space --, version. If Maven is correctly installed, you would be seeing here the Maven home value, Maven installation 3.0.4, the Java home where Java is installed, what is the version of Java, what is your OS, information about the system is all available here. That is how you can confirm that you have configured Maven correctly in your system. So summarizing, how do you set up Maven in your system? Step 1, go to Apache Maven org, download the Maven zip, download the binary version, then you extract it to your some new folder. Then you need to set two environment variables. One is m2_home. That should point to the location where you have extracted Maven, and next you have to update the path variable so that you have your Maven installation location /bin updated to your path. You are not creating a new variable, but you are updating a variable. This completes your Maven configuration. To check it if Maven is correctly configured, you run Maven space --, version. It will return you with the latest Maven version, latest Java version, and some system information. Yeah. So now that we have installed Maven, now let's try to understand what is Maven and some fundamental concepts around it that helps us to realize the power of Maven. Then we can start learning various components in Maven. Primarily, what is Maven? Maven is a software management tool which has three major capabilities. One, it can be used as a build framework, as a build tool that helps you to very quickly and very conveniently build your Java J2EE applications. It's more suited for Java J2EE applications. It is also useful for project management in the teams, for effective project management, and it also can be used for generating documentation of the site. So we use generally Maven for build framework, as a project management tool, and as a source for generating documentation of the site. But in this discussion, from the build and release perspective, we will keep the discussion centered around build framework. And Maven is based on a fundamental concept called POM. POM stands for Project Object Model. It's an XML file and it contains entire Maven information related to project at one place. Okay, let's understand various problems which Maven wants to address. So these are some of the high level problems which Maven wants to address. If you take any typical Java J2EE project, The first problem that we come across is that there are a lot of jars in the project. A typical Java JTA project will have lot of components. Each component will have its own artifact. Generally, the artifact is a jar file. So there will be multiple jars belonging to the application. So we need to maintain. So whenever you are writing a compile script, whenever you are writing a script to run the test cases, you need to put those jars in the class path. Any mistake there would end up in compilation failures or build failures. So maintaining all those things in your class paths in your script is a difficult task. Second, sometimes your project depends upon multiple third-party jars. So we need to have our scripting in place to include all those dependent jars, maintaining them, and then we need to ensure that during compilation those jars are available, and when we are shipping to customers we have to bundle them and ship to customers. Okay, when we are packaging, those jars should be included. Okay, so the difficulty lies in maintaining those jars and remembering their versions and writing scripts to include all those jars at the time of compilation, at the time of packaging, at the time of distribution is another difficult area. The third thing that's quite common in Java JTA projects before Maven was that development teams tried to have their own practices, their own folder structures for their projects. So what it boils down to is too much of scripting. If you go to one company, you will find Java in some folder, tests in another folder, and you need to write custom scripts to bundle from those locations. You go to a different company, again it will be completely different way. So what Maven tried to bring to the table is an organized structure for projects, for Java JTA projects. Hey, if you are having a project which builds a war file using struts and Hibernate or Spring and Hibernate, you follow this model. If you are just a servlet and JSP, you go for this model. If you are building a simple Java application whose output is a jar file, go for this model. So what Maven has introduced is concept of templates, asking people to follow these templates, and many people from many organizations have come forward and shared their templates, saying, hey, if you want to go for a Java project with a beans, with EJB involved, you take this template, you take this source code structure, and Maven takes care about setting it up for you. You need not do any scripting to do anything. So that's the biggest advantage when it comes to using Maven when teams follow standard project structure. And with Maven, you need to hard the script. You have seen, right, how you set up Java compilation. You have to go to and look at script, get it and put it in your build script, then you update your paths and all that. With Maven, you need not do any scripting. It's all there with Maven if you choose a particular template for your source code structure. So these are some of the big problems which Maven tried to address in its design. One, the ability to handle multiple jars in the project at the time of compilation, at the time of creation of jar, at the time of bundling, etc. And even if you have third-party jars, lot of third-party jars, Maven takes care about bringing them, placing them in your system, setting up the class path, and providing to you when you are doing packaging and when you are doing distributing to customers. So this is another biggest advantage which we get with Maven. So how does Maven do all these things? Okay, we understand now that these are all problems. There is no doubt about it. But how does Maven try to achieve it? It looks pretty good. When I say I don't want to set up class path, when I say I don't want to handle complex third-party dependencies on my own with my own scripts. So how does Maven do it? Let's try to understand it now. Okay, now what I am going to do now is, so far I have installed Maven, I have configured the path, and we try to understand that there are certain problems with scripts like maintaining component jars, managing dependencies, type of third-party system, third-party jars, and the lot of effort to be spent in scripting. Now I will try to show you how we are able to solve the problems with Maven. Maven actually works on the concept of repositories. Maven has a lot of public repositories like Nexus, like Artifactory. There are certain public repositories for Maven which actually stores all the dependent third-party jars in a well-organized manner. So if I say my project build depends upon JUnit, you just need to tell that. You don't need to download JUnit jar, put it in some location and then give a path. If you say my application depends on some Lucene search jar, you just need to tell that. You don't need to go to search inlet where Lucene is available, download it and put in somewhere in your system and give that path in your script. You don't need to all these things. Maven has a lot of public repositories who maintain all these third-party things in well-organized structure with version, name of the jar like that, and you only need to tell I want this jar. Maven takes care about downloading it from the repositories and placing that into your system, setting up the path and all those things. Okay, I'll show you how Maven does that right now. So let me go to some drive, some E drive. I'll just make a directory where I'll pack this Maven. So I'm just going to the directory. Now I will type a sentence. Maven archetype :generate. So when I do this, Maven works. I have told you that Maven works on the principles of templates. So here template is actually referred in Maven as archetype. Archetype is a particular model for a particular type of Java project, Java J2EE project. Now when I say generate, I will get a lot of templates now which I can choose from. So before I do, I'll just show you that I have just created an empty directory here. So this is the empty directory here. Now after I have installed Maven, the only command I am typing here is Maven archetype :generate. Now when I type enter, now you will see Maven setting up my internal repository. There are two types of repositories. Public repository where you have all the third-party jars available, and when I run Maven archetype generation, it will download those third-party jars which are required into my system and set up an internal repository in my system. So it is downloading all the things. It will take a few minutes. Probably you can also parallelly run that command if you have installation done. Go to any directory and just type Maven archetype :generate. Now when I run the Maven archetype generate command, it has downloaded the required things to set up Maven in my system from the public repositories, and then you can see on the screen it has given lot of numbers and along with that some information is provided. See, for instance, if I want to, what does this indicate? This is a template, this is the archetype number, and it is showing me if I use this number what kind of project will be set. If I just scroll above, for instance, if I want to set it up a Spring project, or if I want to, these are multiple types of projects, which ready-made projects. Say you can also write this onto a write this onto a file, okay, by greater than symbol, and then you can also see all these things, you can go through it. Suppose if I want to generate a project structure for a Mojo framework. Mojo is another web application framework. Or if I want to generate a project for Spring framework, here you can see the number for that. And if I give this number, it will generate a project which suits the Spring framework project. So here it's giving default as 251 as the number. Let's see, it's okay for me, I'll go with the number 251. I am just pressing enter here. So it will generate a project structure whose number is 251 by default. Because multiple companies will contribute to Maven. So today it's 251, tomorrow it may be something else. So you need to, it's not that you freeze the number as hard as 251. Today it's 251, tomorrow it can be something else. So you need to go through the archetypes and pick up what kind of project structure suits your project. So I'm just pressing enter here. It's asking me the version that I want to associate. So I will say I'll say version 1.1. Let's see. So it's again for this project 251, for this project model, whatever are required, it will fetch now. It is asking me to give a group ID. Group ID is like you can give any value here which is like more or less like your package structure. For example, in the Java project that we have seen, I'll show you that how to understand a group ID concept. We have seen a project structure in the Ant practice, if you remember. We have taken a simple Java project. Here you can see net, SourceForge, Cruisecontrol, and we have seen this, right? So this packaging structure is actually called as the group ID. Group ID is the packaging structure. So let me give some packaging structure, say for example org.usm.training. Okay, this is the group ID for me. This is the packaging structure I want. And I say artifact ID. I'll say train artifact ID means what is the name of the jar file that we want. I will say training app. Okay, and then version 1.0 snapshot. Let me retain whatever it is. Package org USM training. I am okay with that package convention. Move on. It's asking for a final confirmation. The group ID is org USM training. Artifact name is training app. Version is 1.0 snapshot, and I am just confirming it. So you can see now an information build success. Okay. So what did I do now? What I have done now to summarize is I have told Maven that I want a project structure which is having an archetype number 251, and Maven has run that archetype, generated a project structure which is in line with 251, and it has given me. Now how can I see what it has done? So let me go to E2013 batches and Maven practice. Let me go to this folder. You can see now that their folder is created training app. In that you can see a source and pom.xml created here automatically. And if you see source, you can see main and test, a directory structure created. And you see here Java. There are some dummy content here, but that's okay. It has created org, USM, training, and it also created some dummy code for me. And if you go here, test, it has again created the structure, and it has placed a test case also for me. So it has created a dummy training app just on giving some information. So if you run this structure in your company where you join, you will get the same thing. So what you need to tell to developers is, hey, here is the Java code. Everything is created. You just remove this file and place your actual Java files. That's all. Similarly, you can go to test and ask them to commit the test cases, to put the test cases in USM training, and here you can ask them to put the test cases. So what Maven has done for us is that with taking minimum information about the group ID, about the packaging structure that we want, about the name of the jar file that we want, and then it has taken an archetype number and then it has created everything on its own. Okay. Now that it has created a structure, what all we want development teams to do is show them the Java folder and ask them to put the Java code there. Show them the test folder, ask them to put the test cases there, and Maven will take care about compiling, building, jar, deploying, all things automatically. Okay, how does Maven do? Okay, just because I am putting some content there, how does Maven do all these things? The heart of any Maven execution lies in a file called pom.xml that you see in the screen. Maven automatically generates a pom.xml for each archetype. You see archetype 251, for that template it generates a pom.xml. You tell 501, it generates a project structure along with it a pom.xml. You tell 700, it generates the source code structure for that 700 archetype, and along with it generates a required pom.xml. It is in this pom.xml where all information related to compilation, building, dependencies, deployment, everything will be stored in this pom.xml. So let me open that pom.xml. You can see here multiple things in this. First of all, let's focus on this part. This is information about the project. What is the group ID of the project? What is the artifact ID, name of the artifact? What version are you building? What version are you building? And finally, you have here what type of packaging you need, jar or POM, or is it a WAR file, is it EAR file? You have to specify here. You need not specify. Based on the archetype, it will automatically give those things for you. And what is the name of your app? Training app. Okay. Then it also, if you want to specify any ant-like properties, you know how to set properties in ant. If you want to set some properties here for your build process, you can set them under this properties tag. And this is where, another the beauty of Maven is about. You can set dependencies. You can specify, I want JUnit, I want this version, and it will take care of going to the public repositories, fetching that JUnit, placing that in your some location, and then putting the class path dynamically to your at the time of your build. All this will be taken care by the Maven itself. What all you need to do is whatever dependencies you want, you have to list them in your pom.xml. If it is a standard project, it will automatically prepare that dependency list also for you. And where does it fetch and put all those things? Let me show you that. If you go to your documents and settings, where is it? Documents. Just a minute. See, users. You can see here in your users folder, you have a folder called .m2 created. Okay. In this you can see repository setup. Now Maven has downloaded all these things from a public repository, and it has created all these structures for you. It has put all the information about third-party things in your system, where to find which jar, what is the version, and all those things. It has downloaded and set it up for you. Now all these jars are already downloaded in your system, and Maven has set them into class path by default. For all of you, if you have run the archetype command, if you have run that command, you would find that there is a .m2 folder created in your system, and in the .m2 folder you have all the dependencies can very organized, placed in an organized manner. Name of the artifact, okay, is common connections. In that artifact ID, version and actual jar. Group ID, artifact ID, version and your actual jar. This is the structure you associate with any artifact in Maven. JUnit or DOM for J is the group ID. This is the artifact ID. This is the version. This is the jar file. So any binary that you associate in Maven will have this structure. Group ID will be at the top. Inside that there will be artifact ID. Inside that there will be version. Inside that there will be your actual jar file which is associated with name. So in our case, once we build this project, the group ID will be arg.usm.training. In that there will be a folder training app. In that there will be a folder 1.0 snapshot. In that there will be a file training app.jar. This is how Maven maintains information about every jar, every binary that you are generating. That's how Maven sets class paths in a very clean manner. It follows a standard structure for every artifact that you generate. So you can see here M2. This is repository where all the things are there. This is your internal local cache. Whatever downloads happen from internet, Maven sets it inside your .m2 folder. So next time onwards. Now I just run a command for today. Then the details of which we will try to take it from next session. So I will just say now, I will go to the project. So in Maven practice, my project is training app. So I am just going to that project. CD. Okay. Now I say Maven package. I am running a command Maven package. Now you can see it started building the project. So for building project, it wants some third party things. It is downloading all of them. So whatever it requires as dependencies, because this is first time you are seeing lot of downloads. But once you do another project, the amount of download that you see will be lot less. Because most of things will be already available in your local cache, which is nothing but your .m2 folder in your users directory. It's downloading things. You can see on the screen, it has done compilation. Okay, then it has run the test cases, unit test cases. It has also built the jar and the build is success. Now if you just go to your training app, you would find the target folder here created. In that you will have a lot of reports being generated, and you also have your training app version 1.0 snapshot available. Okay, see the power of Maven with this example. You have not done anything, right, with respect to writing a script for this particular project. What all you have done is choose an archetype which suits your project, and you just have run the command Maven package. One single command you have run, and it has done all the things that you need for your build process. It compiled, generated class files, created jar file, and if there are test cases, it has run the test cases, generated the reports, everything over. So in this session, what we have seen is how do I set up Maven in my system, what are the environment variables, so choosing an archetype, with Maven archetype command, and then running the sample project, understanding pom.xml, and see how the jar files have been created. We have also looked at the repositories, how your local cache is set up in your .m2 folder. So in the next class, what we would look at is more detailed view of the anatomy of the pom.xml. What does the pom.xml contain? What are the various pieces, individual components in pom.xml, and how can I extend building Maven projects for more complex projects, more complex Java J2EE models. Hope you understood the first session that we have today on Maven.